My name is Bryson Wingate, and this is the Project One game called Gravity Drop. Now, Gravity Drop is a survival game based on one mechanic, gravity reversal. The player avoids the obstacles by pressing the space to switch between the floor and ceiling. Now, as you can see, the goal is to survive as long as possible. The timer in the upper left tracks the survival time, and the speed indicator in the upper right shows the player current difficulty level. And as the player survives longer, the game becomes harder because the obstacle speed gradually increases. Now, if a player runs into an obstacle, the game will enter the game over state, and the player can immediately restart by pressing space, as of right now. Okay, and as you can see. Now, switching over to the game design document, the goal here was to create a simple arcade-style survival game focused entirely on one mechanic. The player survives by reversing the gravity to avoid the obstacles, and I intentionally kept the scope small by using only one screen, one obstacle type, one input, and of course one mechanic. Now for system architecture, of course before coding I had to divide the game into several systems. Player, input, obstacle, collision, game state, and rendering. And of course, each system has its own specific responsibility. Now, for the mechanics specification, the core mechanic, of course, was gravity reversal. Pressing space automatically changes the gravity direction and moves the player towards the opposite surface. And of course, everything else in the game, such as the parameters, would support this mechanic. Now, of course, my target experience here was challenge and tension, and players would have to constantly react to incoming obstacles while trying to beat their previous survival time. Now, as far as for technical specifications, the game uses a player object and an obstacle array to store state, and it was built using HTML5 canvas and JavaScript without external libraries, of course. Now, as for UI and flow, the game has three primary states, of course: playing, game over, and restart. And the interface displays survival time, speed controls, and the objective. Now, for out of scope, I intentionally excluded features such as power-ups, sound effects, multiple levels, and additional obstacle types to keep the project focused on the core mechanics. And I would obviously focus on these in the future. And before implementation, I identified difficulty scaling, object spacing, and gameplay variety as potential challenges, and these became the balancing issues during development. Now, for the architecture of the game, the player object, of course, stores the position, the velocity, the radius, and the gravity direction. And as for the key down event listener, this is basically the input system, and the game listens for the space key presses, and if the game is over, the space restarts the game. Otherwise, the space reverses the gravity, and this is where the core mechanic is implemented. Let's see. So to update player, basically the update player handles the handles the movement. It applies the gravity, the updates the position, and it prevents the player from leaving the playable area. And for the choose obstacle sides, it's up here somewhere. Basically controls the obstacle variety. It prevents too many obstacles from spawning on the same site consecutively, and basically, yeah, it's limited to 3. So now for a spawn obstacle, it creates the actual obstacles and adds them to the obstacle variety. And for the update difficulty, this function increases the obstacle speed and the gravity strength over time. Now for the obstacles itself, this function here moves the obstacles and handles the spawning. It uses distance-based spawning so that the obstacle spacing can remain consistent as the speed increases. And for the function check collisions, This function detects when the player intersects with an obstacle, and if a collision occurs, then the game enters the game over state. Now, of course, then we go over to the draw. We input the coordinates rendering by drawing the background, the obstacles, the player, the HUD, and the game over screen when necessary. And then the game loop here serves as the central controller here. Each frame updates the player, check updates obstacles, updates collisions, updates the timer, and draws the game, and also requests the next animation frame. Now, for question one, describing the game loop uses request animation frame. Now, each frame updates the gameplay systems, renders the game state, and schedules the next frame. As for question two, where does the game state live? The game state lives in the player object, the obstacles array, of course, and variables such as game over, survival time, obstacle speed, gravity strength, distance since last spawn, last obstacle side, and same side count. Now, where the core mechanic lives for question three, of course, it's this line. The player gravity direction equals -1, and this line directly reverses the gravity and implements the mechanic described in the game design document. And for the last question, what would I break first if I added a second mechanic? Essentially, the player system would require the largest changes because the architecture assumes one input and only one input and one gameplay action. Now, for the post-mortem, my biggest success was keeping the gravity reversal mechanic simple and easy to understand. However, the biggest challenge was balancing the obstacle generation. Initially, increasing speed caused obstacles become space farther apart, and then I had to solve this by changing the obstacle spawning to a distance-based system since the distance since the last spawn variable. Another issue was repetitive obstacle patterns, and like I said, too many obstacles would appear on the same side and like five in a row. And I solved this by limiting how many obstacles can appear on the same side consecutively. Now, if I continued development, of course, I would add sound effects, visual effects, and additional obstacle types. Now, overall, Gravity Drop remained faithful to the original game design document while incorporating improvements that had to be discovered throughout testing. And that is my presentation.